everyone. You know, this is actually more intimidating than I thought it'd be. Yeah, so when I got here these last couple days, I saw a lot of these like academic presentations. I was like, wow, I'm in way over my head, and this is like really advanced stuff. All this like super high level AI, super high level like statistics analysis. But I also learned throughout my time here, especially today, with these keynotes today, that the basics are also really important. We need to set a foundation before we can actually get to the more high-level analysis and tools. So my name is Lieutenant Tim Dawson. I'm the lead mobility test operations analyst at the Air Force Operational Test and Evaluation Center, Detachment 5, over at Edwards Air Force Base, California. And today we're going to talk about leveraging, ooh, my bad. So while she's doing this, today we're going to be talking about leveraging data science and cloud tools to enable continuous reporting. Is it up? We can put it up.
Yeah. Oh, I see. Enable content. Oh, it's locked. That's the problem. PowerPoint is locked up.
That never happens.
Let's record. Task. So there we are. Okay, let's start this one again real quick. And cancel. Don't need that. And which one were we on here? Let's see. Powell. Let's see. Okay, gotta go a little further.
Sorry,
Here, Dawson. Thank you. To enable the content here.
Oh, that's
Switch. Should be good, sir. Thank you.
Sweet, appreciate it. All good. So today we're going to be talking about leveraging data science and cloud tools to enable continuous reporting. So today we're going to talk about who is AFOTEC, like what do we do at the Air Force Operational Test and Evaluation Center, and how we manage data today, and then how we're going to think about managing data tomorrow. So there's a video up here that's it's on the desktop, I guess. So sorry for that.
Just need to go out of PowerPoint.
Yeah.
For a second. And do you know where it is on the desktop? Or is it?
No, I asked. I sent it in like a week ago.
Here we are. Is it, oh, to show here?
Yeah.
Is it inside this folder?
I don't know.
Here it
Yeah,
is.
there we go.
And there's no sound.
There's no sound. Okay. No, it's on here.
Ah,
Okay, I can talk without the video.
Okay.
It's fine.
thank you, sir. And let's get this cleared again.
So basically, let's talk without the video. So basically, at AFOTEC, I want to bring up another slide. Can you get the slides up here? Oh, there we go. There we go. Appreciate it. So basically, at AFOTEC, we're here to conduct operational tests. There's a difference between developmental and operational test. In developmental tests, testers really focus on like the specific, like what is this plane or is this system supposed to, is it doing what it's supposed to do? In operational tests, we test if it works in an operational setting, if operators can actually use the system. So that's basically what the video kind of goes through. And then I really want to talk about these 3 rows of pictures and really hammer down like what we actually focus on. The first row of pictures, you'll see all of our new programs. So in the Mobility Test Operations Division, we care about things like the new Air Force One, the KC-46A next generation tanker, and the T-7 high performance aircraft that's going to be training or going to be used for training students to go into the fighter and bomber communities. The next row, you'll see our sustainment programs, things like the B-52 re-engineering program, the radar modernization program, as well as emerging systems like the Agility Prime. The last row that I really want to talk about real quick is our constant investigation into emerging cyber threats. So, a few years ago, General Brown, the Air Force's the Air Force Chief of Staff, talked about a challenge. He issued a challenge to all airmen to accelerate change or lose. So at AFOTEC, we answer that challenge by trying to deliver combat capability at the speed of relevance, faster and smarter. And how do we do that? We respond to that challenge by what we call the 6 key principles. Right here in this presentation, in this setting, I really want to zoom in and focus on 2 of these key principles. One is early OT involvement, early involvement in operational test. And the other is continuous feedback, being able to report and continuously deliver inference and insight to our leaders and stakeholders. So let's start with some examples of early OT and continuous feedback. So back in 2021, the Air Force, the AMC, the Air Mobility Command, issued an interim wanted a request for information to enable early KC-46A operational fighter taskings and augment the joint force. Basically, what this means is AMC came to us and they asked, hey, can you guys find the data? Can you guys find something to see if we can actually refuel the F-15, F-16 with the KC-46 in an operational setting versus in a more controlled setting? And so what we did was we actually went into the data, all hands on deck, and actually dug through and saw and drew insight from our data. What we were able to do was deliver that insight back to AMC so that they could allow the KC-46A to operationally refuel the F-16 and F-15. This is a more modern example, or a more recent example is in 2022, the KC-46, AMC actually did a very similar thing, and we were able to refuel the F-22 and F-35A stealth fighter aircraft to be able to operationally refuel from the KC-46A as well. So how are we able to do those data pulls and actually draw that insight for RFI? So at AFOTEC, we collect data through primarily 3 main channels. Our first channel is user observations, so things like usability or workload surveys. We also collect data through onboard flight data, like in the KC-46 example, things like timing, quantities, how much fuel are we giving, what are the start and stop times for giving and receiving fuel. And then the last channel is maintenance data. Maintainers deliver multiple maintenance metrics, and we need to be able to collect and store that data, so failure rates, maintenance times. And below all these bullets, you'll see a little kind of example of one of our observational surveys, what we'd give out to operators for them to fill out and give back to us. So like I kind of mentioned a bit earlier, observational data right now is collected on paper, transcribed and stored in Microsoft Excel, and then we do that RFI, that request for information. As you mentioned earlier, sir, you talked about Excel being a really common approach and often a fallback because it's so accessible, so easy to use. Like everyone knows what Excel is and what it's capable of, and it's all on all government computers. These 2 examples here are just like kind of to hone in on what we use. We use the Excel to create sort of databases, right? That's how a lot of the general public who don't know what databases are, they call Excel a database if it has a ton of information in it. We also use Excel macros to actually transfer the data around and kind of manipulate it to what we want it to be. So let's talk about the process right now for getting data from survey to insight. So the first step is we generate the surveys. We use those Excel macros, and then we generate the Word document paper form of surveys for us to print out. We'll then have operators complete the surveys. We'll hand out the surveys to them. They'll kind of fill out whatever they need to fill out, their own demographic information, like their name, their unit, like their hours, and then they turn the surveys back to us. The next step is we'll transcribe those surveys from that Word document that I showed you earlier, back, like print it out, and then we'll transcribe it back into a digital version of that Word document. We'll then take a Excel macro, because Microsoft products all talk to each other, right? And have those Excel macros actually read in all those inputs in the Word document back into a database, quote unquote. Clean it up and then put it wherever. And then we go into all those Excel sheets, that database I keep talking about, which is a collection of Excel sheets, which could range to over 50 Excel sheets per major program. And it's since all these sheets are not intrinsically connected because they're not a relational database. It's really dependent on a knowledge of the specialized data structure. Like, how do you know that like sheet number like 51 here talks to like sheet number 12, right? But we do go in and then we analyze and report on that data. So let's talk about some limitations. Like I said, there's paper form requirements. When you print out paper forms, you could lose the forms. You could also have AFOTEC issues. If you do lose the forms, that may be actually sensitive after the data has been filled out. It could create an AFOTEC issue. Second limitation is multiple disparate tools and apps. We have, like I said, we have like Microsoft Excel, we have Microsoft Word, and we have things like Jump or R or MATLAB, things that people are familiar with and they go into use to ingest, store, analyze their data. We also have a really high manpower demand for repetitive tasks. We keep talking about automation. We keep talking about like trying to streamline our processes. But right now, with our current method, it takes 2+ hours per survey pack with a dedicated analyst to get from survey to insight. How I define survey to insight is from actually getting those paper forms out to the operator, to ingesting it into the database, perform the analysis, and actually being able to provide meaningful insight. With that, without a dedicated analyst, we can have a backlog up to 2 weeks during peak periods, just because everyone's working on different programs, everyone's like trying to shift between their different programs, and not all hands on deck can actually focus on this particular program to get through that backlog. So let's talk about some considerations before actually going into what I think our solution will be. So time to insight right now is dependent on request complexity, data size, and manpower available. So we need to simplify and automate work wherever possible. Also, new systems are driving exponential data growth. It is a data-driven world today, or as mentioned earlier, a data implied world today. And we need to leverage an increased, and we need to make use of the increased data channels and rates that are available through the multiple like high-tech programs that we're starting to test over and over. We also have a analyst turnover rate. Like if you're in the military, you'll understand that officers, we have a 3 to 4 year turnover rate. So the turnover cycle plus just like a new analyst will come in, see a problem, try to solve their issue, and then leave. And then a new analyst will come in and be like, hey, like, I don't know how to use this tool, or this tool is not meant for my problem at hand anymore. So this turnover cycle can turn into a larger issue. Also, existing digital solutions are not compatible with the Air Force network. Like I mentioned earlier, we're working with surveys a lot. So I'm talking about like SurveyMonkey, Qualtrics, Google Forms. They all have limfacts when it comes to either cost, classification, or customization. Because we want something that we can own, that we can kind of shape into what we want it to be and deliver the insight that we want it to deliver. So what are we looking at for data tomorrow? Like I mentioned earlier, we're really working on Excel, Word, and paper forms right now. But we want to move onto an app, like a one-stop shop for anyone to go in and be able to find surveys, to take the surveys, to provide, to look at insight, and to actually analyze the data that's stored in our system right now. And all this can be done on a tablet. What we use is a Microsoft Surface Pro. So before we actually get into what we have, let's see what we can learn from. So I like to use industry as an example, as some of my peers may know. I'd like to look at Netflix and Spotify. Why I like these companies is because their goals are really similar to ours. They want to make the most use of their data as possible in order to make as much money as possible. As well, they want to reduce their costs as much as possible as well. And how they decided to do this was actually work with their data on the cloud. Netflix uses Amazon Web Services. Spotify uses Google Cloud. And what these companies are able to do is they're able to draw so much data and draw so much insight and provide so much insight in a way that as users, you don't need to know how the data works. You don't need to know how the coding works. You just use it and just awed by the fact that Spotify knows what you want to listen to like at 9 a.m. So I was a math major in college. I like to think in terms of equations. So I put up like a very simple linear equation for you. So on the left-hand side, you'll see what we have right now, what we need to do as analysts in the operational test community. On the right, you'll see our goals, our goal to deliver combat capability at the speed of relevance, faster and smarter. So what's in the middle? How do we get from point A to point B? Well, I think the solution is in the cloud. With increasing data channels, the cloud will provide us with that missing piece that we need to actually push us farther ahead. So back in 2019, the Air Force CDO, the Chief Data Office, announced capabilities for the visible, accessible, understandable, linked, and trusted data platform, Vault. This platform is basically a one-stop shop for analysts, engineers, anyone in the Air Force, and possibly in other parts of the DoD to actually come in and use industry standard tools on the cloud to create products, to ingest data, to work with data, to report on data, and to store it. So this is a little kind of mind map, you could say, of what Vault actually gives us capability of. Things like Amazon Web Services, which we can use to store and compute data. Things like Databricks, which we actually use is our user interface. As well as things like SQL, like we can actually store data in a SQL format, or Delta tables as Amazon works with, to actually store our data in a relational manner. So let's take a look at what we decided to use as our solution. So what we did was we take the test points that are developed by operators, analysts, engineers. We take those test points and see, like, okay, this is what we need to test to be sure that this system is combat capable. We'll take those in and store it into an Amazon Web Services database, or into a database within Amazon Web Services. Once we have that, we'll actually take the data through those channels that I was talking about, the surveys, the bus data, the maintenance data, and actually put that into the database in combination with the test points. From there, we'll be able to connect everything together and deliver, like on the south side here, you'll see a dashboard. And a dashboard will provide a really high-level view for stakeholders, senior leaders to see where the program is, like what is the program health at the moment. On the east, you'll also see the analysis portion, and this is to dig deeper for analysts, people who actually know like what they need to really look for, to actually use tools in the cloud to draw like even more insight deep into the data. And in the future, we'd like to combine both the dashboard and the analytics and the data that we have to actually create reports. We have all our reports are like they're on paper right now, but they were all like born in a computer. They're born from Word documents. So all these words for the most part remain the same, but the numbers change over time. So if we can build reports that actually take the numbers from the database and take the numbers from our insights continuously, then we'll be able to create reports more frequently and faster. So let's I want to show you the steps real quick of how our app works. So we generate surveys just with the click of a button, just type in what we need to fill out and then hit submit. Then operators will log in with their CAC into our app, and then they just type in a URL and then fill out the surveys just as you would on SurveyMonkey and then hit submit. After that, distributed processing, basically the cloud, AWS, actually handles all the calculations through with our functions and provides insight. Now, since the computer now handles all that ingestion, all that storage that took so long for analysts to do, analysts can now take that time that they now have on their hands to focus on building tools for AI reporting, being able to go into Stack Exchange or go into GitHub or something and look for tools that might actually help them in the future. So, last thing I want to show you is a quick demo, what have we done. So, here's our prep page, an example of our preparation page. Basically, an operator will log in and see okay, this is my name, these are my demographics. Hit login. After they've logged in, they can see a prepared survey for them, and a test conductor can actually go in and prepare a survey. After the survey is prepared, operators will go into their page, which is the collect page, and see okay, I can fill out all this information that I know in an easy to read format for them, and hit submit. After that, an analyst can go in. This is a really basic form right now that will grow as we collect more data, and actually perform kind of basic analysis. And this is a really basic early version of the dashboard that we'll have to show to senior leaders and stakeholders. So, on the horizon, we really want to be able to expand this system to other systems so that we can actually be able to compare data from, for example, the T7 that this app is going to be working on in real time, to KC46 or to future programs. And we also want to make sure that this app's sustainable. Like I said earlier, a lot of tools that analysts make, really, they have an expiration date. And I think something that's built in the cloud, that's built using standardized processes, can actually be sustained. And industry uses data managers to make sure that everything's sustained in a standardized format. And we want to keep everything sustainable that way. So, in summary, I talked about what AFOTEC does, how we manage data right now, and how we intend to manage data in the future. And now I'd like to just open up the floor to questions and see, since we have a couple minutes left.
Hi, thanks for the talk. I have a few questions for you. So I like the idea of being able to cut down on that hand jamming time for the analyst, but there's still the issue of data validation. So that's the first question in terms of how do you actually do that? How much time does that take? Because you have to, I'm assuming you have to go into the app and try to figure things out. And the second is, so this looks great. The app you talked about looks great. I was wondering, how many people and what the team looked like that created this product. So that way, you could try to spread that word to other organizations that might want to create something similar, to see what kind of personnel they might want to bring on to their team.
Okay.
Yeah.
Okay. First part of the question is, I think, a bit easier to answer. Validation is something that honestly it's really hard to do without human input. And over time, initially with the T7 program right now, we're looking at just having a portal within the app for an analyst or someone who actually knows what the data is supposed to show to go through and see okay, that looks right. The comments look like they belong to the right question. But over time, as we learn more about patterns of things that we need to look for in the data, then we can actually write algorithms to check for us. Second part of the question, I think, is I guess I'm a bit slightly confused about the question itself. With our team basically looks like it's a bunch of me. It's me and a few other analysts and engineers. We just decided, we have a process. It's taking a long time, and we're not as we're not as prepared, like manpower wise, to handle large amounts of data. So we just took the initiative and went and made like, okay, we have Vault. Let's try to make something that works. For other organizations that want to create something like this, if this works for you, it's not hard to move this over to someone else that needs it. But if they want to create something similar, that doesn't really like intertwine with this at all, like isn't the same thing, then it doesn't take like that many people. I think it just takes like the right ideas and the passion.
So I guess as a follow-up, what kind of skill sets should like a hiring manager look for? Like, hey, like I need to bring this person onto my team in order to fill a gap. Like, what skills were required to get this thing produced, aside from elbow grease?
So personally, I used R. I used Python. My degree was in applied mathematics, but I did a lot of studies in computer science and data science. But honestly, just people who have taken classes in data science know like what to look for, like what the horizon is 5, 10, 15 years in the future of what data kind of should look like, and have an idea for it and a passion of it. They'll take their knowledge of computer science or of mathematics or whatever and run with it. As long as someone has a decent amount of programming experience in whatever language, they can take it and run with it. That's my opinion. But I'm sorry I couldn't answer your question like so much better.
We have time for probably a couple more questions. We have a question online that I wanted to present. And that was, how did you choose your dashboard tool of Shiny, Dice, Tableau, or Dash, or another type of tool?
Yeah, much easier question. So basically, we had two choices. Like in my opinion, we had two like big choices. One was R Shiny, and one was Plotly Dash. We chose R Shiny. My colleague actually found it because they have this really awesome package called Shiny Surveys, and you don't have to know any web development. You don't have to know like React.js or anything to make something really pretty to actually have people fill out. So that's the only reason initially that we actually chose Shiny, was because we could have a package that looked like Google Forms that was easy to use for operators.
Hi, Brian Conway from IDEA. I really appreciated your talk. I think simplifying survey distribution and data collection is a really smart way to move forward. As you know, obviously in OT, there's a lot of organizations that have equities with the data that you're collecting in surveys. So I was just curious if you could speak a little bit to the information sharing aspect of this and getting survey data and analysis into those equities like DOT&E and IDA.
I think a big part of this is because the data is not stored in like a proprietary format. It's not stored in Excel. It's not stored in a bunch of like Parquet files. It's stored in SQL-like, essentially SQL tables in AWS. So we can use those sharing capabilities that are intrinsic to AWS and to those types of tables to share with other people. And because they are relational tables that are theoretically named pretty well, someone else can actually come in and be like, hey, I know how to relate some of these data together, and I know who to talk to if I have any questions. So I think it's built into the concept itself.
Thank you.
Thanks, everyone.